All right, guys, so this is quiz 3 review. Hopefully this helps you. If you still need more help, you can tune into the Zoom sessions for this review. Okay? All right, here's question 1A. So you know that f of x is 2x minus 1 over x plus 2. You know g of x is x minus 1 over 3x plus 2. And they're asking you to find g of f of x. Okay, I rewrote it like that versus how it was given because I think it's easier. So I'm going to take that f of x and replace it with what f of x is, which is that. And then I go into this g of x, and right here and right here, I replace it with that fraction. So it's going to be 2x minus 1 over x plus 2 minus 1, big long fraction bar. So there's the main fraction bar, and I made it big. And then it's 3 multiplied by that g of x, which is right there, plus 2. So this is pretty messy. On the top, you need to get a common denominator. So I'm going to take that main fraction bar and keep it big. And on the top, the denominator's common denominator is going to be x plus 2. So this guy right here already had the x plus 2. So I'm just going to write 2x minus 1. This guy right here, he's missing the x plus 2. So I have to multiply the top and the bottom by x plus 2. Distribute the negative, and I get negative x minus 2. A lot of people put negative x plus 2, but you have to distribute that. Right here, you have to remember how to multiply fractions. So if you have a over b multiplied by c over d, you just go ac times bd. So when I multiplied this right here, this 3 does not get multiplied by the x plus 2. Because the 3 is not on the bottom. This is 3 over 1. So the 3 gets multiplied by the 2x plus 1, so that's 6x minus 3. 1 times x plus 2 is x plus 2, and you have a plus 2 right there, okay? That minus 0 right there should be a minus 2. Okay, so on the top, you have x minus 3 over x plus 2. Getting a common denominator on the bottom is going to be x plus 2. This guy right here already has the x plus 2, so I can just write 6x minus 3. This guy right here is missing the x plus 2, so I distribute and I get 2x plus 4. So now I'm going to continue over here. I have x minus 3 over x plus 2. I'm going to make that long division, bar division symbol. 6x plus 2x is 8x, and negative 3 and a positive 4 is a positive 1 over x plus 2. And now I'm going to flip the second guy upside down. So it looks like that. This x plus 2 cancels with that x plus 2, and your answer is x minus 3 over 8x plus 1. And you guys know that you can't cancel those x's because they're stuck to the 3 and stuck to the 1, and it would be rude to the 3 and the 1, okay? They also want the domain. So when you're finding the domain, you check the denominator, anything that was ever in the denominator. So I'm going to do it in green. So see all these things that I'm highlighting? They're all restrictions. Okay, I'm not going to highlight that. I'll just do my answer. Okay, so what do we have? The 1 doesn't give us anything. That doesn't give us anything. X plus 2 tells me that x cannot be negative 2. Those are all x plus 2's. 8x plus 1 tells me x cannot be equal to negative 1/8. There's my domain. Okay? All right, now, so the next question is to find g of f of 2. So write it like this, g of f of 2. And you could find f of 2, figure out what that is, and then plug it into g of x. That's always how I've done it. But see this g of f? that was actually the answer to part A. So I already know that that's g of f, and now I just want to go of 2. So I'm going to go 2 minus 3 over 8 times 2 plus 1. That gives me a negative 1 over 17, and I'm done. 8 times 2 is 16 plus 1 is 17. That is not the typical way I do it. Usually I go, okay, find f of 2. So go into your f of x and put in a 2. Oh, my machine's being a little weird. Okay. Okay, so f of 2, I don't know what's happening, but it's 2 times 2 minus 1 over 2 plus 2. So that's going to be 2 times 2 is 4, minus 1 is 3, 2 plus 2 is 4. And now you would find g of 3/4, which you could totally just call that 0.75, it's the same. So it's 0.75 minus 1 over 3 times 0.75 plus 2. So if you grab your calculator, you'd have to go parenthesis, 0.75 minus 1, close it, divided by parenthesis, 3 times 0.75, close it, no, not close it, just 3 times 0.75 plus 2, close it, enter, and you get this bad decimal. But if you go second PRB, enter, and that gives you the same thing, negative 1 over 17. So the button that you push to get there is second, and then the button diagonal PRB, and then it turns it into a fraction. Okay? All right, that was 1A and 1B. Here's question number 2. Okay, so here is your f of x. Here is your g of x. And they're asking you to find f of g of x and the domain. So very similar to what we just did. So here's your g of x, put it in. So this is f of 2 over x plus 1 is equal to, now go into that f of x, and in both those places put in 2 over x plus 1. So it's 2 times 2 over x plus 1 over 2 over x plus 1 plus 3. So remember, don't get confused on this right here. The 2 is not on the bottom, this 2 right here. It does not get multiplied by the x plus 1 because that's 2 over 1. So now you go, 2 times 2 is 4, 1 times x plus 1 is x plus 1, plus 1. All over. Common denominator on the bottom is going to be x plus 1. This guy right here already has the x plus 1, so you don't have to change anything. This guy right here is missing the x plus 1. So you have to go 3 times x plus 1. That's 3x plus 3. Now I need to get a common denominator on the top. So big long fraction bar. Common denominator on the top is going to be x plus 1. This guy right here already has the x plus 1. So you just write down the 4. This is 1 over 1. It's missing the x plus 1. So 1 times x plus 1 is x plus 1. The bottom is 3x plus 5 over x plus 1. Now, the top is x plus 5 over x plus 1. Write it as a division symbol, 3x plus 5 over x plus 1. Take that division, make it a multiplication, flip the second guy upside down. This x plus 1 cancels with that x plus 1, so your answer is x plus 5 over 3x plus 5, and that's it. Okay? To find the domain, remember you go through, and anything that is ever in the denominator is a restriction. So all these things, make sure you include everything. So your domain is x cannot be negative 1. The 3x plus 5 tells you x cannot be equal to negative 5/3, and that's it. Okay? All right, here's question 3. show that they are inverses by finding these things, okay? So here's your f of x. Here's your g of x. So I need to find f of g of x, and I need to find g of f of x. And it says show that they're inverses. So remember, if they're inverses, those are both supposed to be equal to x. And it says show, so I know it's going to work. Sorry, if it said determine if, that would be a different story, okay? So take that g of x and replace it with what g of x is, like that. Now go into that f of x right there, and where you see an x, replace it with that. So it's 2 minus, parenthesis, cube root of 2 minus x cubed. Now the cube and the cube root undo each other, so it's 2 minus. Now this is a little tricky. So it's minus, and I wouldn't even require that you write this step, but since those cubes and cube root undo each other, it actually would look like that, and you have to have parentheses around that step. So when you distribute the negative, it's a negative 2 plus x. 2 minus 2 is a 0, and you're left with an x. Okay? This one right here, this is going to be g of 2 minus x to the third. So I'm going to go in here, that g of x, and put in 2 minus x to the third. So it's a cube root of 2, and then a negative, and then again, you have to have parentheses right there because the negative affects all of the x, which is this. Now you distribute, so it's 2 minus 2 plus x to the third. 2 minus 2 is a 0. So now I have the cube root of x to the third, and that gives me an x. Make sure that you write that step, because if you cancel the 2's and analyze that the cube and the cube root is just an x all in one step, I don't know which one you did first, and you have to cancel the 2's first. So remember when I taught you this, you wrote up at the top, take one step at a time. So that's what you need to do, okay? All right, question 4, find the inverse. So here's your problem. And f of x is y. So I'm going to make my y an x and make my x a y. And then I'm going to solve for y. So I'm going to move my 2 over, and I have y to the second equals x minus 2. And now I'm going to square root, and I get f inverse of x equals plus or minus the square root of x minus 2. Okay, now I know that's wrong because basically you're going to have a sideways parabola is what that's going to be. And that's not a function. So I know it's either going to be the positive or the negative. And the way you're going to determine that is part B is asking you to graph it. Okay, so I'm going to go like this. So the original graph is a parabola right here, shifted down 2. Okay, so I'm going to go down 2, make a dot. When you take your quiz, if you can't print the actual quiz that I attach because you don't have a printer, make sure you do your graphs on graph paper, okay? Because some of you did not do that on the final and it was not good because it was so like messy. Okay, so go, actually it's not down 2, I did that wrong, it's up 2. Okay, so you're gonna go up 2 and make a dot, and then it's a normal stretch, right one up 1, left one up 1, right 2 up 4, left 2 up 4. So it's about like that. Okay, but you have to notice in the directions, it says x is greater than or equal to 0. So basically this is like a piecewise function. Greater than 0 is to the right. So over here to the left, all of that has to go. And I know my circle is going to be closed because I have an equal sign, okay? So that's my f of x. Now remember that the inverse is a reflection across that line right there, y equals x, and I just freehanded that. So what's this going to look like? Well, this is 0, 2. So this would be 2, 0 over there. This is 1, 3. So this would be 3, 1. And then you can kind of see what's going to happen. It's going to look like that. And I'm going to label it the inverse. You guys, if a square root has a negative out in front, it's a reflection across the x-axis, which would make it look like that. And that is not what that graph looks like. So now I know that I can go back and get rid of the negative, and it's just the positive. Okay? That was for A and B. When you do your homework, you guys, some of you are not labeling A and B. So label that A and label that B so I can grade your homework more efficiently. Okay, here's question 5A. Find the inverse. So again, we have x equals y to the third minus 1. I switched the x's and y's. Now I'm going to solve for y. So I have y to the third equals x plus 1. To get rid of the third, I'm going to cube root. So I have y equals the cube root of x plus 1. So one thing they're super picky about, you can't write it as y equals. You have to write it as f inverse of x equals. So just make sure you label that correctly, okay? And then they ask you to graph them both on the same xy axis. This is such a bad way to do your graphs. If you don't have graph paper, Google graph paper, printable graph paper, and you can totally find some, okay? Okay, so the original problem is right there. That's a cubic shifted down 1. So there's that center point's down 1. And then the stretch is right 1, up 1, left 1, down 1. And the next one is 2, 8, which would be here. And then negative 2, negative 8, which would be about like that. There's your graph. And you have to be really careful to label that, okay? And now I'm going to graph that line y equals x. And then I can do the diagonal thing if I want to. It's kind of hard because I don't have a normal grid. I'll go ahead and try. So I know it's going to hit here. I'm just going to actually come up with some points, I think is what I'm going to do. Will be better. I'm trying to figure out what color to use. Okay, so there's that. So this is 1, 0. So this would be 0, 1, like that. This is 0, negative 1, so negative 1, 0. And then you can kind of see that it's going to curve over, go up, hit like that, and go like that. Okay, like I said, please use graph paper. That doesn't look that bad, but for sure it has the potential for being super sloppy. So there's 5B, okay? Question 6 is super similar. So they want you to graph the inverse, okay? So just give me 2 seconds to draw in a grid. Okay, so if you look at that given graph, it hits the point, looks like about 1, 2, 3, 4, maybe negative 5, something like that. And then it hits about right here, not quite 1. Then it definitely hits 1, 1. And then it hits 2, 2. And then it kind of curves over and it hits 3, 3. Like this, so it's going to be kind of like this. Okay, all right, so that is the original. Then I'm going to take my pencil and go like this. Okay, the problem is I didn't curve it very well. Sorry. So these kind of have like protrusions a little bit. Would have been nice if I had. So it kind of goes like that. So it curves on both sides of that thing like that. Okay. So then let's reverse these points. So 0, negative 5 would be negative 5, 0. Okay. They're going to hit at the same spot. So I'm just going to do something really fast. Oh yeah, we're good. Yep. Okay, I'm just doing it on the actual graph paper as I do this. So this is about 0.8 comma 0, so this would be about 0 comma 0.8, like this. And this one was 1, 1, so this one's going to be 1, 1, then it's going to bump, then it's going to hit, then it's going to bump, then it's going to hit. So this kind of goes like this, look. So this is going to go curve, a little bump, go like that. This guy's going to be super flat like that. It looks like that. I know that's awkward and kind of strange, but that's how you do it, okay? You can look at the answer key as well to get a better graph probably. Okay, question number 7. Graph y equals 4 to the x power, okay? So you can do this so fast. So if x is a 0, 4 to the 0 is a 1. If x is a 1, 4 to the first is a 4. And it's going to go like that. And I'm going to have an asymptote like that. Okay, and then they ask you lots of different questions, like find the domain. Well, the domain is like so much easier to get off the graph. Domain and range for sure. Domain is left to right. That's everything. Range is bottom to the top. That would be 0 to infinity. You could also say y is greater than 0. Don't put both. It's one or the other, okay? The x-intercept is easy because you can just look. So that would be 0, 1. Oh, no. X-intercept, pardon me. 0, 1 is the y-axis. X-intercept is none. It's never going to touch it. The y-intercept is 0, 1. Vertical asymptote or horizontal asymptote. Well, you don't have vertical, so that's none. Horizontal touches the y-axis, so you have to write y equals, and it touches it at 0. Okay? Okay, so that was question 7. Here's question 8. I'm actually going to use 7 to help me do 8. So question 8 is y equals 4 to the x plus 2 minus 3. Okay, so the first thing you have to do is you always have to graph the parent, which we actually have on question 7. And then once you have your parent, you do the adjustments. If there's a reflection, meaning a negative right here or a negative right there, you have to do those first, but there are no reflections. So the negative 3 tells you to take your graph and shift it down 3. The plus 2 tells you to go left 2, okay? So when I graph these, you guys, I always start with the asymptote because I think it's the easiest thing to do. So if I go down 3, 1, 2, 3, there's my asymptote right there. And then all I'm going to do is I'm going to take those 2 points that I have on my parent, and then I'm just going to kind of move them a little bit, okay? So this is 0, 1. I'm going to go down 3, 1, 2, 3, left 2, 1, 2. It would put it about like that. Okay, so it's right there. And then this one, it would be 1, 4. So it would be here. And then I'm going to go down 3, 1, 2, 3, left 2, 1, 2, right there. Curve it in. And there's my answer. Okay. And then they want all those things. So domain, look at the graph, all real numbers. Range, it's going to be a negative 3 to infinity. The x-intercept is going to be a little tough, so I'm going to skip it for a minute. The y-intercept is going to be a little tough as well, so I'll skip it. Vertical asymptote and horizontal asymptote. So the vertical asymptote is none. The horizontal asymptote is y equals negative 3. Okay? Now, to find the y-intercept, it's going to be easier. I'm going to let x be a 0. So if I let x be a 0 right here, then you'd have y equals 4 to the second minus 3. 0 plus 2 is 2. 4 to the second is 16. 16 minus 3 is a 13. So it wouldn't hit that y-axis until clear up at a 13. To find the y or x-intercept, I'm going to let y be a 0. So then I would have 4 to the x plus 2 minus 3 is equal to 0. Then I pull that 3 over and it becomes a positive. And now I'm stuck, and when you're stuck, you convert. So this is going to be log base 4 of the other side, which is a 3, is equal to x plus 2. Pull the 2 over, and I get negative 2 plus log base 4 of 3. And that's all I can do. Please make sure you never put your answer in decimal form unless you're told to, which we were not. So we're going to go negative 2 plus log base 4 of 3, comma 0, and that's it. Okay? All right, that was number 8. Here's number 9. So number 9, we're going to graph a log now. So you have y equals log base 4 of x. So a log graph begins with the letter L, and it has an asymptote that looks like an L. So there's your asymptote. Remember that it always hits the point 1, 0, and then you go back to the origin. Make sure you go back to the origin, not from that dot, and you go right, whatever that number is, and then up 1. So there's your graph like that. Okay, and then they're asking you to find the domain. Look at the graph. That would be 0 to infinity. The zeros close with a parenthesis. Range is from the bottom to the top, all real numbers. And then we have x-intercept, y-intercept, vertical asymptote, horizontal asymptote. Okay, so x-intercept, you can look at that. That would be 1, 0. Y-intercept is never going to hit it. Vertical asymptote, that's what that is, the red one, crosses the x-axis at 0. Horizontal asymptote would be none. Okay? All right, and then question 10. Hey, Maddie. Sorry, my daughter's being loud. I'm recording for my class, so can you close your door and turn that down, please, honey? Thank you. It's okay. Okay, so here's question 10. Okay, so again, you're supposed to graph the parent, which is right there. And then no reflections, because there's no negative in front of the log and no negative in front of the x. By the way, if the negative was in front of the log, that'd be a reflection across the x. If the negative was in front of the x, it would be a reflection across the y. But that is not happening. So the plus 1 goes up 1. The plus 3 goes left 3. And like I said before, I always start with the asymptote for 2 reasons. One reason is then I'm not going to forget it. A lot of people forget to do it. And the other reason is it kind of just starts my graph off and helps me keep my bearings, like, you know, where am I at? Where am I going? That kind of thing. Okay? So you have a vertical asymptote at x equals 0. And now you're going to shift it left 3. Moving it up obviously doesn't change it. So there's that asymptote, okay? Find that point right there, which is 1, 0. Go up 1, left 3, 1, 2, 3. There's that point. This one was 4, 1. So I'm going to go left 3 and up 1. There's the point. Curve it in. There's your graph. Done. Okay? And now they want domain, range, x-intercept, y-intercept, vertical asymptote, and horizontal asymptote. Look at the graph. The domain is negative 3, but it never touches it, and bigger. Range is bottom to top, so that would be everything. X-intercept is going to be ugly. Y-intercept is going to be ugly. That asymptote is vertical, so the horizontal would be none, and the vertical is going to be x equals negative 3, okay? To find the y-intercept, you're going to let x be a 0. So I'm going to let x be a 0. If I put a 0 right there, I'd have log base 4 of 3 plus 1. That's all you have to do. Do not make that log base 4 of 4, because this one has nothing to do with the log. That'd be like adding x plus 1. They're totally different. You can't add those things together, okay? To find the x-intercept, you have to let y be a 0. So you'd have log base 4 of x plus 3 plus 1 equals 0. Then I'm going to convert it. So it's 4 to the other side, which is a 0. Oh, no, sorry. First I have to move my 1. So I have log base 4 of x plus 3 equals negative 1. Now I convert it. 4 to the negative first equals x plus 3. That gives me x plus 3 equals 4 to the negative first is just 1/4. Then I pull my 3 over and it becomes a negative. And it looks like that. And I can do that in my head, and I know that's negative 2 3/4. So I'm going to go negative 2 3/4, comma 0, and I'm done. Okay? All right, that was number 10. Okay, here's number 11. Okay, so what I see are 4s on both sides. So if I can get it to say 4 to this equals 4 to that, then I know this and that would have to be the same. So the square root of 4 is 4 to the 1/2. And this is 4 to the 2x minus 1. So I've got it. 4 to the 1/2 is 4 to the 2x minus 1. So I know that 2x minus 1 must be equal to 0.5. I can write 0.5 because 1/2 is exactly 0.5. I'm going to pull my 1 over. So I have 2x equals 1.5. Divide by 2, and I get 0.75. Okay, now you do not have to check this. You are not required to check this. The reason you're not required is because it wasn't given in log form originally, but you can check it very easily. Okay, on the left side, the square root of 4 is a 2. So if I plug in 0.75 right there and get a 2, I know I'm right. So if you have time to do this on the quiz or on the final, why wouldn't you? Okay, so go 4 to the parenthesis, 2 times 0.75 minus 1, close it, enter, and I got a 2. So I know I got that perfectly right. Okay, number 12. 3 to the 2x minus 1 is equal to 9 to the 3x plus 5. Okay, so you're trying to get your bases to be the same, and you always change the big number, which is the 9. You never mess with the 3. So see the 3, leave that alone. I know I can write my 9 as a power of 3. 3 to the third, no, 3 to the second is 9. So now I've got my bases the same. Now I do have to simplify the right. So I have 3 to the 2x minus 1 is 3 to the power to a power tells you to multiply. So that's 6x plus 10. Sorry, there's a jet overhead. You guys might not be able to hear me very well. So 3 to this equals 3 to that. So I know 2x minus 1 must be equal to 6x plus 10. 6x comes over, you have a negative 4x. 1 comes over, it becomes a positive, you have an 11. So x is a negative 11 over 4. Okay, no requirement to check, but I would totally check on the quiz and the final. So here's what I would do. I'd go negative 11, divide 4, store, enter. Then I'd put this left-hand side in, and I'd go 3 to the parenthesis, 2 membar, enter, minus 1, close it, enter, and I got 0.00079. If I get the same thing over here, I got it. So go 9 to the parenthesis, 3 membar, enter, plus 5, close it, enter. I got the exact same thing, so I know I did it right. Okay, number 13. Okay, so again, you always change the big number, okay? So see that 16? 2 to the something gives me 16. So I know that I can make those the same. So leave the 2 a 2, change the 16 to 2 to the something, and is actually 2 to the 4th. So then 2 to the 7x minus 5 is 2 to the 4x. Those exponents must be the same because the bases are the same. Move my 7x over to the right, and I get negative 3x equals negative 5. Divide, x equals positive 5/3. And again, not required to check because it wasn't given in log, but store that 5/3 in, put it in the left, put it in the right, and you should get the same thing on both of them. Okay, number 14. Okay, so we're solving a log and we're stuck because the log is alone. So when you're stuck, you convert it. So this is going to be 5 to the other side, which is 2, is equal to x minus 1. That gives me x minus 1 equals 25. Pull the 1 over, x equals 26. A very important part of this problem is you are required to check it. So literally you have to write the word check and then you stick in the 26. So it's going to be log base 5 of 26 minus 1 is equal to 2. So a lot of times, you guys, people do their check like lazy and like not good, and you're not going to get credit for it. So you literally have to take the original problem and put in the 26, just like that. And then you have to actually grab your calculator and put this in. So you're going to go the log of 26 minus 1 is 25. So I'm just going to go log 25, close it off, divided by log 5, close it off, enter, and I got a 2. So I'm going to write 2 equals 2, and then I'm going to come over here and I'm going to box my answer, and I walk away with 100% certainty that I did that right because it checked. Okay, here's number 15. And if you look at this, you're stuck because all you have on the left is just a single log and there's nothing over there that's not part of the log already. Now I'm going to convert it. So this is log base 10. So it's 10 to the first is equal to x plus 2 over x. 10 to the first is just a 10. So I'm going to put a 1 underneath it. And then I'm going to cross multiply. So I get 10x equals x plus 2. Pull the x over, it becomes a negative. 9x equals 2. Divide, x equals 2/9. I am required to check because it was given in log. You always check from the original. So it's the log of 2/9 plus 2 divided by 2/9 equals 1. Okay, this is a little tricky to put in. The only reason it's tricky is because you have to add parentheses around the top and around the bottom. Okay, I know the right hand side is a 1, and now I'm going to put the left hand side in my calculator. So I'm going to go log parenthesis 2 divided by 9 plus 2, close it, divided by parenthesis 2 divided by 9, close it, enter, and I got 1 equals 1. Totally checks out, 100%. Okay, question 16. Okay, so I see log 5 on the left and I see log 5 on the right, but the problem is you've got this 2 sitting out here. So I'm going to pull this 2 up as an exponent. That's one of the rules and I can utilize that. So now I know if I have log base 5 equals log base 5, then what I'm taking the log of must be the same as each other. So now I know x to the second must be equal to 3 minus 2x. Pull those over to the left. So x to the second plus 2x minus 3 equals 0. Then I'm going to factor x and x. 3 is 3 and 1. Signs are different. Biggest is the positive. So that gives me x equals 1 and negative 3. And I am required to check. You always check from the beginning. So it's going to be log base 5 of 1 squared equals log base 5 of 3 minus 2 times 1. Okay, grab your calculator. Actually, you know what? That squared was not a squared originally, it was a 2 in front. So I have to check it in exactly the original method, or how it looked. Okay, so everybody go 2 log 1, close it, divided by log 5, close it, enter, and I got a 0. Okay, and then I'll be looking that you found a 0 on the right. So you go log 3 minus 2. You could go times 1, but 2 times 1 is just 2. Close it, divided by log 5, close it, enter, and you got a 0. So that one worked, okay? Now, sorry about these jets. Now I have to check x equals negative 3. So I'm going to go 2 log base 5 of negative 3. The second I write that, I know it's not going to work because I'm taking the log of a negative number. I don't want to have an incomplete check here. So I'm just going to very quickly write it out. And then I'm going to write invalid solution because it doesn't work. Then I'm going to come right here and I'm going to write x equals 1, and that's what I'm going to box. Some of you in other questions had boxed like x equals 3, like you did this and then you did this and you said invalid. Don't do that, okay? Don't box the invalid. I don't think they're going to like that. So you just need to, box the only answer. That's correct. Okay, so that was 16. Question 17. 17 is very simple. You can't take the log of a negative. So x minus 5 has to be greater than, or let's see. Yeah, it has to be greater than 0. You also can't take the log of 0. Log of 0 gives you an error. So it's just x is greater than 5, and that's it. Super simple, okay? Here's your f of x. Find the inverse and find the domain and the range of both, okay? So this is 18. So here is your f of x, and they want you to find the domain and the range of the original, and the domain and the range of the inverse, okay? Well, this is y equals 4 over x plus 1. If I look at that right there, I can see that the domain of that is x cannot be 0, because I have an x on the bottom and I can't have a 0 on the bottom. If that domain is x can't be 0, then this range is y can't be 0. So I've already got those down. Switch your x's and y's and solve for y. So move your 1 over. So you have 4 over y equals x minus 1. Now, I'm going to cross multiply, but I'm not going to distribute. Some of you are going to want to divide both sides by 4. So here's what some people do, just so you guys know. They multiply by 1/4, and then they're like, okay, those are gone. And they get y equals x minus 1 over 4, but that's false because that y is actually on the bottom. So you'd have 1 over y equals that. So I don't recommend that. I just think cross multiplication is so easy. So I'm going to cross multiply, but I'm not going to distribute. So you have y times x minus 1 is equal to 4, and I'm trying to solve for y, so I divide by x minus 1, and I get 4 over x minus 1. And I label it as the inverse, not as y. If you look at that denominator, that tells me the domain of that is that x cannot be 1, therefore the range is y cannot be 1. Okay, that was 18. Here's 19. So the amount of iron in a substance decays according to this equation. Okay, A sub 0 is the initial amount. X is the number at the time that has passed in millions of years. And A of X is the iron, milligrams of iron. Okay, so there are 100 milligrams initially. So I'm just going to erase that A sub 0 and replace it with 100 because A sub 0 is initial. One will be 30 milligrams of iron remaining. So you have two variables. One is A of x and the other one is x. Well, the 30 is the milligrams. So I know that's going to be my A of x. So it's going to be 30 is equal to 100 e to the negative 0.2665x. Okay, now my variable is stuck in the exponent. So I know I'm going to have to convert it into log, but I can't convert yet because I'm not stuck. So I have to divide by 100 and I get e to the negative 0.2665x is equal to 30 divided by 100, which is 0.3. And now I'm stuck, so now I convert it. So it's log base e of 0.3, that's ln 0.3, is negative 0.2665x. To solve for x, you divide. So it's ln 0.3 divided by negative 0.2665. So here's one thing I need you guys to understand. This is the exact solution. Exact means you haven't rounded, there's nothing approximation, but these directions actually tell me to round 2 places past the decimal. So you go ln 0.3, close it, divided by negative 0.2665, enter, and you get x equals, actually I'm not going to even put x equals, I'm going to go 4.52, and this would be how long, right? And it was in x, so million years. That's it. Okay. All right. This is actually checkable, just so you guys know. Take that value right there and hit store. So go store, enter. Put it right here in for x, and when you do, you should get a 30. So go 100 second ln negative 0.2665 memvar, enter, close it, enter. I got a 30. So you can check it in about 20 seconds. Okay. All right. Question 20. Solve this. So it is log base 3 of x plus log base 3 of x plus 2 is equal to 1. So I have 2 logs and a number that's not a 0. So I'm going to condense and convert. So those 2 logs are added. So when I squish them, they're going to be multiplied. So it's going to look like that. Okay. There's nothing wrong with how that's written, but I don't do that. So if what I'm taking the log of is complicated, I put brackets around it because I think it's more clear. Okay. Sorry. So I condensed, and now I'm going to convert. So it's 3 to the other side, which is a 1, is equal to x times x plus 2. Distribute the x, and I have x to the second plus 2x. That equals 3. Pull your 3 over to the left. It's going to become a negative. Then factor it, so it goes to x and x. The 3 is going to go to a 3 and a 1. Signs are different. Biggest is the positive. Looks like that. That gives you x equals 1 and x equals negative 3. You have to be careful because this was given in log, so you are required to check. So if I write x equals 1, please make your checks very clear. You write the original problem down and you put in a 1. Okay, I got a 1 on the right, so write that down. Now I have to put in the left-hand side and make sure that I get a 1. Okay, make sure you actually do this. So do this with me. Go log 1, close it, divided by log 3, close it, plus log 2 plus 1 is a 3. So I'm going to go 3, close it, divided by log 3, close it, enter, and I got 1 equals 1, so I know x equals 1 is a solution. Now I'm going to check x equals negative 3. So it's log base 3 of negative 3 plus log base 3 of negative 3 plus 2 is equal to 1. And now I'm taking the log of a negative number, which I cannot do. So I'm going to say invalid solution. You have to write those words. Then I'm going to come over here and I'm going to write x equals 1 and I'm done. And I know without a doubt that I just got that right because I checked it. Okay, here's number 21. So you know log base d of y is 1, and you know log base d of x is negative 2, and you know log base d of z is a 3. And they want you to analyze log base d of x to the second over z to the third times the fourth root of y. Okay, so look what people do. They say, okay, x is a negative 2. So I'm going to erase that and I'm going to put in a negative 2. This is not saying that x is a negative 2. It's saying log base d of x is a negative 2. Then they'll go, okay, z is 3. So that's going to be 3 to the third. That's not true. That's not saying z is 3. It's saying log base d of z is 3. People will say, okay, this y is a 1, so I'm going to put in a 1, and that is false because log base d of y is 1. Okay, so I'm going to change all those back out. So it looks like that. So if you look back at your notes, I asked you to write like very clearly that you have to expand fully first. Okay, so I'm going to write log 1 time, 1 for the x, 1 for the z, 1 for the y. The z and the y are going to be negative because they're on the bottom. So it's going to be log base d of x to the second minus log base d of z to the third minus log base d of the fourth root of y. Now, the fourth root of y is the same thing as y to the 1/4. So I'm just going to put that there. Now, that is not fully factored, and I think this is an all or nothing question if it appears on the final. And so if you start putting things in right now, you're going to miss it. So those exponents have to come down. So it's 2 log base d of x minus 3 log base d of z minus 1/4 log base d of y. Okay, now I've got it fully expanded, and so now I can plug those in. So log base d of x is negative 2, so that's 2 times negative 2. Log base d of z is 3, and log base d of y is 1. And then I'm just going to put it in my calculator. So go 2 parentheses negative 2, close it, minus 3 parentheses 3, close it, minus 1 divided by 4. I'm not going to do the parenthesis 1, close it. You could, but it's just multiplying, so it's fine. Hit enter, and it's negative 13.25, and I know they'll give it to you because it's exact. That decimal ends. Okay? Okay, question 22. So they're asking you to find f of g of 3. So the first thing you have to do is find g of 3. So if you look at the table, there's a column that looks like this. So x, and then f of x, and then g of x. So when x is a 3, g of x is a negative 1. So I know g of 3 is negative 1. Now I have to find f of negative 1. So I'm going to go to the column that looks like this. When x is a negative 1, your f of x is a negative 5. That's it. Okay? All right, 23. Expand this. So we kind of already did that on the other problem. So I'm going to write log 3 times, 1 for the x, 1 for the y, and 1 for the z. Okay? So it's going to be the log of x to the third plus the log of the square root of y, but the square root of y is y to the 1/2. The z's on the bottom, so minus log of z to the 4th. Pull the exponents down, so it's 3 log x plus 1/2 log y minus 4 log z, and you're done. Okay? 24 is the exact opposite of that. So you're condensing it. Okay, so you're going to go completely opposite direction. So there's a couple of different ways to do this. I kind of hate that negative right there, honestly. You could pull the whole negative 1/4 up. Then you'd have an x to the negative 1/4, and then you'd have to pull your x to the bottom, and it would be an x to the 1/4 on the bottom. I don't like that. And so I'm just going to leave the negative there. I'm going to take the 1/4 up as a fractional exponent, and that is the 4th root of x. So I pulled the 1/4 up, I left the negative, and it's the 4th root of x. This guy, I'm going to pull the exponent up, and this guy, I'm going to pull the exponent up. Now, the reason I left the negative is it's so much easier because look, I know I'm going to have a fractional. What I'm taking the log of is going to be a fraction. Anything that's a negative goes on the bottom. Anything that's a positive goes on the top. So the 4th root of x goes on the bottom because it has a negative sign. Who cares that it comes first? It doesn't matter. This guy's going to come on the bottom, and I'm going to put that z to the 3rd in front because it's, it's how you're supposed to write it. And the y to the 5th is a positive, and it's going to go on the top, and that's your answer. Okay, I think that's the easiest way to do it. Okay, question 25. 25 is the last one, and this is kind of a tough one. So I see my bases, a 2 and a 5, and I want to change the big one, which is a 5, to the small one, which is a 2. 2 to the 1st is a 2, 2 to the 2nd is a 4, 2 to the 3rd is an 8. I can't make a 5 be a 2. So remember in the lesson that you watched, I said, okay, that this is weird. So if it's a weird problem, you take the log of both sides. So this is the log of 2 raised to the 3x minus 1. It is not log base 2 of 3x minus 1. This is wrong. This is right. Okay? So don't write the 2 as a base. It's the log of 2. This one right here is the log of 5 raised to the negative 2x plus 2. So pull that 3x minus 1 down, and it's multiplied by log 2. Pull that negative x plus 2 down, and it's multiplied by log 5. Distribute the 3x, and you have 3x log 2 minus 1 log 2. Distribute this, and you get negative x log 5 plus 2 log 5. And now I'm trying to solve for x, and I've got x's on the right and x's on the left. So remember, I'm going to put everything that has an x on one side and everything that doesn't on the other. So this guy is going to stay. This guy is going to come that way. So it's plus x log 5. Now I'm going to get everything that doesn't have an x on the other side. So this log 2 comes over. This 2 log 5 is just going to stay. Now I'm going to take out an x, and when I do, I'm left with 3 log 2 plus log 5 equals log 2 plus 2 log 5. This is multiplied by the x, so to get rid of it, I'm going to divide. So it's log 2 plus 2 log 5 divided by 3 log 2 plus log 5, like that. I want to make sure you know how to put this in as a decimal. Basically, you just have to put parentheses around the top and the bottom when you put it in. So just practice this with me really fast, okay? Go parenthesis, log 2, close it, plus 2 log 5, close it, close it. you had to close it twice, one to close the 5 and one to close the top. Then you go divide, parenthesis, 3 log 2, close it, plus log 5, close it, enter. And let's say they wanted you to go 2 decimals, it'd be 1.06. So just make sure you know how to do that, okay? Okay, so guys, besides that, I'm also doing a Zoom session on Thursday to help you with any questions. And your quiz is on Friday. Sometime during the day on Friday, you have to take it, okay? Thanks, you guys. Hope you're doing great.